guys, and welcome to my channel. I'm Dr. Benita, and today we'll be talking about snakes. Yes, snakes, a topic that I'm very sure most people don't like, but I just feel like you don't have accurate knowledge about this guy, so you just hate them for a lot of misconceptions that are just out there. So I'll just put this out there before we start. Snakes, just like every other animal, have been perfectly put in our world to help maintain it and make it better. You feel like snakes, but yeah, see, honestly, they're very important. They help maintain our food chain, and that goes a long way in maintaining the ecosystem. And there are actually other benefits that we derive directly from these animals, and you might not understand it, but as we go on, I pray this knowledge helps to enlighten us that they are really not as bad as we think, and rather we are really benefiting from them. I'm not saying there are no downsides to it, but there's a lot of advantages attached to them also. So I'll start with a broad introduction before I streamline it to specific factors that I find fascinating or interesting about snakes. So snakes, I would like to define as venomous reptiles. And mentioning the term venomous now, I would like to differentiate between a venomous animal and a poisonous animal. So venomous animals are those animals that have anatomical structures that they use to inject their toxins into the body of their host. It could be prey, it could be a predator, anyone. And let me use an example. Snakes now, they have fangs. Those are anatomical structures that they naturally have. The scorpion, they have stingers. Those are natural anatomical structures that they have. And then you talk about the stingrays, those are aquatic animals. So this is what they use to inject their toxins or venom into their host, and that's why we call them venomous animals. They have these anatomical structures naturally. Then for poisonous animals, they don't have any structure by which they use to put this into the system of any host or any animal in general. How you get intoxicated by these animals is usually either through touch or when you ingest them. For example, we have certain toads. Toads are amphibians, so they are able to release these toxins on their skin, and if accidentally people that maybe eat them, you ingest them, or animals most times are actually the ones that fall prey to this. Like, say for example, you have a kitten that just comes out and doesn't really know what a toad is, just picks it up from the floor and begins to lick it and play. It's going to ingest this toxin and then to come down with toxicity. Or there are actually certain birds, a lot of birds. So for people that like to eat wildlife, you just go and hunt one bird that you don't know the origin from the bush, you now go and cook it and eat, you now go and have intoxication. So those are actually what we call poisonous animal. This is how you get intoxicated by them. They don't come and then put it in your system, just like snakes and scorpions and the rest. So that being said, let's move to snakes properly. So I think let me start like this. I've defined what a snake is, what snakes are generally. Let me come and break it down now and give you like very, very broad classification and just make sense into a lot of things. So generally we have what we call venomous and non-venomous snakes, but we have poisonous snakes, and there just happen to be just one species of snake, and that is called the tiger keelback. So it's just one, so let's just leave it like that. And then once I say poisonous snake, I've defined what poisonous animals are, so you can just put it into that category, or we'll focus more on the venomous one and then the non-venomous ones. So funny enough, there are actually more non-venomous snakes than there are venomous ones. A lot of people don't just know, they just attribute, when they just see a snake, venom. But based on the statistics that were generated by the World Health Organization, they said that 85% of all snake species are actually non-venomous. Just 15%, not so low, I would say, but at least relative to how a lot of people talk about it, is not as high as people think. Just 15% of total snake species are actually venomous. So let me just briefly talk about the non-venomous one, then we move to the guys that usually worry people, which are the venomous ones. So funny enough, I realized that most non-venomous snakes are usually very large. I didn't say all, but most. So just like when you talk about your pythons, I mean, they're very large. The boas, they're big guys. Anaconda, that's the world's largest snakes. These are all non-venomous snakes. But there's a peculiar guy I like, which is non-venomous, but it's very slim and small. It's called Samorphis sibilans, aka farmer's friend. And you want to know why it's called the farmer's friend? I feel like if you're a farmer and you see this snake in your farm, you should be grateful. First of all, it's non-venomous, so even if it bites you, you probably be thinking about just taking antibiotics and anti-tetanus, because the fang of a snake is not sterile, so you actually have to take further precaution, not just about the venom. But the importance comes that I don't know how God did it or how nature was able to bring that balance. They actually feed on the young of venomous species of snake, like cobras and the rest. So if you have the snake in your farm now, and then it helps you feed off the young of this venomous species, you should actually be glad, because I mean, they will not grow up to now harm you directly. So that, in a way, I feel like is a biological checker. It helps to control the population of venomous species biologically, naturally. So if I'm maybe a farmer, I feel like you should get a pet Samorphis sibilans and just keep in your farm. That will really help you. So that's by the way. So let's move to venomous guys proper now. I'm going to try to use a lot of classifications to just put them based on their importance, and then I'll then finally talk about reproduction in snakes. So that will just cover across all snake classes. So for the venomous now, the major families that any of these ones can be attributed to, we talk about the family Elapidae. Most times you just say Elapid. So popular, I'll just give you like one or two very prominent examples so that you know how to narrow it down. These are where your cobras are and mambas. Yes, this class contains one of the most venomous classes of snakes. You know now, the black mambas, cobras, and the rest. Those guys could be nasty. Then the next class we move to is the family Viperidae. That's the viperids. You talk about rattlesnakes, you talk about vipers, the pit vipers, and so on. The next family we move to is the family Atractaspidae. That's the Atractaspids. And these are usually small, mainly African snakes. You start talking about snakes like the burrowing Atractaspids, and then the I'm trying to remember the other one. It's not coming now. Okay, let's leave that. At least I've given you an example. So we now move to this based on these broad classes. These are the snakes. So let's move to based on the type of venom they produce now. Funny enough, there's actually a very close relationship between the family of where these snakes belong to and the kind of venom that they produce. So as I'm calling the kind of venom, I'll be calling the family, then be remembering what I spoke, and then you're like, okay, there's a very close relationship. So the first one is the neurotoxic venom, or neurotoxins. So now, mainly the family that you can attach the production of this kind of venom to is actually family Elapidae. That's the cobras and the mamba, as I said. And this kind of venom, it affects your nervous system. That's brain, spinal cord, nerves, all those stuff. And why this is actually very dangerous is anything that affects your nervous system. Usually, mostly death is when due to respiratory collapse. Like you cannot respire, and you know that we can't really survive for long without being able to take in oxygen or respirate accurately. So things like now, the chief muscle of respiration is actually the diaphragm. So once there's actually paralysis of the nerve that innervates this muscle, that's leading to subsequent paralysis of this muscle. Now you cannot inspire or respire, you can't breathe, so you are dying ASAP. That's why you see some of these snakes you'll be hearing go bathe in Isa, tomorrow is far. Most times these are the kind of things that are attributed. You just die from respiratory paralysis. All right, so I'm going to talk about the signs that you'd actually see when there's an intoxication with a neurotoxin. So it affects nerves. As I said, most individuals die due to the respiratory paralysis and obo. Something you can see physically on the body of the person or the animal is things like wet gangrene. You just see one surface that looks like it's shiny, soapy, stuff like that. and then blepharospasm. The person cannot hold a gaze, like you just be blinking. Those are, it's already affecting our nervous system, so you see stuff like that. Then we talk about ptosis also, the person cannot hold a gaze. So those are signs. So we'll now move to the hemotoxin group now. This generally you can link it up with members of the family Viperidae, such as the vipers and then the rattlesnake. So this hemotoxin, hemo is blood, so this affects blood and other tissue. So this could cause pain, swelling, and then you could see bleeding disorders, like could be bleeding from the gum, bleeding from the eyes, bleeding from the ears, like bleeding. You just see like anything that just causing blood destruction and stuff like that. Those are kind of things you see. So you just see anything that relating to a lot of blood disarrays. You can easily say, okay, maybe this kind of envenomation is from a hemotoxic snake. So we move to the cytotoxic toxins now. This, funny enough, you can still now relate it to family Atractaspidae. This actually causes, cyto is cells, so toxic is toxic to cells, so this kills cells and tissues. And in this case now, you actually see like destruction of cells and necrosis. Necrosis means cell death. So once there's destruction of cells, blood and the rest will not flow there, obviously they will die, and then you see like necrotic tissue and all. Then the next one is the cardiotoxic venom. This affects the heart and then the cardiovascular system in general. So you're probably things you start seeing, things like increased heart rate, that's tachycardia, hypotension, just the person can just have cardiac arrest, those kind of things. Then furthermore, okay, now the kind of things that can produce this kind of venom now is not fixed to a particular class. It can just be any one of these venomous snakes, mainly cobras and vipers that have cardiac toxins, sorry. So now, okay, the next one is we have a mixed venom. Most of these snakes can now produce, oh sorry, I said most, some species of snakes now are able to produce this venom in a combination, like mixing maybe the neurotoxic with the, like just mixing them. That is a different thing entirely, but we just try to fit them in the way, like just in a means to have order. Then we have okay, that's the mixed venom. And further still, based on maybe either geographical location, certain factors like availability of food and all of that, even within the same species of snakes, they could actually have a variation in the components of their venom, because of certain of these factors can affect it. Maybe as I said, geographical location and then availability of food, maybe climatic factors, stuff like that can actually affect the potency of, like, so there's a lot of factors that even the same species that you find in different places, the components of the venom will be different because of the factors I listed. So let's leave that. Let's move to reproduction now, generally in snakes. So the major type of reproduction in snakes is either they are oviparous, ovoviviparous, or they're viviparous. So oviparous now, let me start with that. These ones, they lay eggs, then the eggs are kept in a good place with warmth and all of that, then they hatch to now bring out the live young. So most of the examples of snakes here are most boas, pythons, if they fall under this group. Then the ovoviviparous now, these ones, they actually lay eggs, but these eggs stay within the system of the mother, and then it's nurtured within, and then later they are born as live young, but they are now found within a thin membranous sheet that will now rupture afterwards, not a normal thick shell. So that's the slight difference. So this in this case, most vipers are here, pit vipers and some other species of boas, you find them here. So now the last class is the viviparous. But the viviparous, these ones, they give birth to their they give birth to their young life. They just, like, you know, the way we humans give birth to hair. So the embryo like is formed within them, grows and is nurtured, and then they give birth to them life. So most times the example of snakes that you mostly see under this class are usually, you could still see some pit vipers here, and yeah, I think the legs and all of that, you could still see some of them under this class. Okay, just to cite examples, the examples of the species of the pit vipers you can see under this class are like the copperheads and the cottonmouth. Okay, so let me move to the reproductive structures now of snakes. Snakes have what we call the hemipenis, and then they're usually paired and forked organs. So just since they're paired and they're like, probably just call them hemipens, plural. So but the thing now is, snake generally, I think they have a wide range of development. Like you can find some snakes that are very, very primitive, especially all those ones that burrow, to very advanced species. So there are even some species of male snakes that the males don't even have hemipens. They just have other reproductive adaptations, just such as hooks and spores that they use to introduce the sperm into the female. So there's a lot of broad thing. I'm just trying to hit the major points there. And then for the females, they have the vagina just like most other organisms have, and some have very simple reproductive system, while some other have complex reproductive systems. Also, some of their females have specialized organs within them that they are able to receive sperm from the male, house it and use it at will. So there's just a lot around here. Then we have a lot of snakes that are actually nocturnal. They love the dark, and then but we have diurnal snakes that function in the day. So I think this is like relatively very broad introduction about snakes, and I hope you're finding it interesting. So I would like to move to certain factors that I find very interesting about snakes. So first, they have poor vision. Like they have eyes that are very small, but they are not as effective as or well developed as our eyes and that of certain other animals. Though they are able to see objects, they're able to see light, but they can't see fine details like color. They're not able to see that. But in a bit for let's say a balancing of this disadvantage, they actually have a very effective sense of smell. They can just use the sense of smell to navigate their way through and find prey. So I think this is where the Jacobson's organ comes in. The very, very important organ in snake. It uses, or let's say, it senses the smell in the they use the sense smell in the atmosphere, like chemicals. So that way, they even use this for reproduction. Like when they sense smell, pheromones are probably released from the mates. They will perceive it. They know when it's time for mating. They know all of that. And then for their prey now, if a predator is around, the kind of hormones you are giving up, they'll pick it. They know if they're in danger. If there's a prey around, they pick up. So this is actually funny, very, very accurate. So they don't necessarily use their eyes. They don't really always need it. They have effective way of navigating and getting prey. And in addition, they have the heat pits, the heat sensory pits. I'd say they're able to feel the warmth or heat of their prey. That way, they're able to use this to navigate and then find their prey. So I think that's that about that issue. So, and again, their mandibles and their maxillae, that means the upper and the lower jaw, is not fixed. We, like most animals and humans, there's like a joining at this point. They don't have that. It's just there, but there's no joints joining it. So it's just there, it's freely moving. That's why you can see that a snake can ingest a prey that is 10 times its size, because the moment they want to use it, their mouth can open so wide because there's no joining here. So there's no limit. There's limits, but I mean, you get what I'm saying, to how it can open. That's why you see a python would swallow a very big and swallow a human being. That's how they do it. So it goes down. I feel like that's very, very fascinating. All right, so I will talk about, okay, let me just proceed with the factors like that. Then they taste their food before they ingest it, and then they swallow their prey whole. So they don't, it's not the one that they will select this part, this one is not good. They swallow everything. Their stomach acid is so strong that it can digest anything from hooves, horns, bones, but they're not able to digest hair though. So most likely they'll pass that out the same way. So they digest, sorry, they take their food whole and then digest everything completely. Then they poop in stages. The first set of poop that come out is usually very dark in color, and that's because that is protein rich. Then the next set is white in color. That's because that is either that's bone rich, or you could say calcium rich, because calcium is the major component of bone, so you can use either of them interchangeably. All right, another interesting factor about them is that there's what we call dry bite. Funny enough, I always say that a lot of people don't know that snakes, first of all, before I even go to the dry bite, let me explain this point before I move. Snakes only attack, or mostly attack, let me not be too categorical, mostly attack out of self-defense when they feel threatened. A snake will not just see you and want to attack you. If a snake senses you are there, the next thing in the brain is, make a jar, let me escape, let me jump out of that place. But it's not when you corner it to a corner, you want to kill it. Even if it's you are going to defend yourself. And then most times, even by accident, for example, it's dark and you don't know, you step on it. Like, even us that are human beings, how many people will just meet a stranger and then they match you? Some people will just forget and slap you. Like, some people are actually that short-tempered. So imagine an animal that doesn't know. So most times it's when they feel threatened that they even attack. So they usually attack out of self-defense. It's not, if they see you, they want to just escape. They avoid you. They don't even like people. They like their space. That's one funny thing that a lot of people don't know about snakes. So, as I said, they really attack out of self-defense most times. So let me now proceed from this point now. Okay, even if they not happen to attack you now, there's what we call the dry bite. First of all, the venom of a snake, God did not put it there for them to be using it to be killing people, or no. It is first a more like more for even digestion of their food and immobilization of their prey. So what they're using it is generally for their feeding and their survival. They don't want to waste it on humans that they cannot eat, because a lot of these venomous species of snakes are actually very small. They can't even feed on humans, so they don't go around wanting to waste their venom. So I'm just saying, peradventure they even bite a human, maybe out of a very impossible situation, and then they had to bite. This is what we call the dry bite. This means that the snake can actually bite you and not release venom. They are able, yes, they can control it. They won't release venom. We call it dry bite because there's nothing in the bite. In the mind of the snake, he's trying to save this venom for a potential prey that is going to feed. He doesn't want to waste it on you that he knows is not a prey. So it will even, that's why a lot of times you go and say, a snake bites me. They will give you a lot of concussion, and most times it's a dry bite. If not, you would have died, because the only ideal therapy for snake bite with successful envenomation, that's when it releases venom, is anti-venom. It's not any other, all those cock and booting, tonic, most of those things are just gibberish. There's usually no scientific or medical basis as to how those things work. That's a topic for another day. So as I said, dry bite, they can actually not even still envenomate. If they're not envenomate, depending on the snake, even if the snake is not there, there's just a lot of ways you probably have to use to now know what kind of snake. That is still a topic for another day. So that being said, let me still move to another factor that I would say about snakes. All right, so the next factor I'll move to is, and yet again, just like most other reptiles, snakes actually grow throughout their lifetime. Like, they keep growing till they die. All right, and most people don't even know that these snakes that everybody's chatting about, snake venom is actually a very, very important entity in drug formation. Honestly, I'm just going to use some very brief examples to hamper on this point. Okay, so the snake venom is a very, very rich, complex let's say compound. It contains like enzymatic and non-enzymatic proteins. One of the most popular enzymes you see in snake venom is phospholipase A2, and then they have a lot of peptides. So when the way we classify different snake venom, the whole hemotoxic, neurotoxic, there are actually certain components in this snake venom that affects the animal the way it does. For example, now when I talk about the hemotoxic, I was telling you they are bleeding disorder, bleeding from the nose and everything. It just means that in a hemotoxic venom, there's actually a component that prevents blood clotting. So that means the blood is not able to clot and then it's coming out. So do you know that in this can actually be harnessed? Like, you just probably, when they go now, when you're doing all those electrophoresis and the rest, if you can isolate the particular component of that snake venom now that prevents blood coagulation, you just harness it, purify it, so that you're not getting the other stuffs that can cause harm. You just bring it out and then synthesize it in the lab. That is actually a drug. You can produce anticoagulants from them. And now in medical cases like disseminated intravenous coagulopathy, this is a condition where, just like that, somebody's blood will just be clotting, and then it can actually form thrombus. Once there's thrombus, blood cannot flow. Before you know it, just gets to a very small vein or artery, just blocks it. Blood might not be able to go to your heart or return from your heart, and then you might just have heart attack and shut down. So in cases like this, you can actually get some of these anticoagulants, put it in, and then help people like this. And then the next very, very important aspect of drug is in cases of when you're producing, okay, even the antivenom is from snake venom used to produce, so you still need the snake venom to save somebody from snake bites. That's what, yes, antivenom is produced from snake venom, in case you do not know. So the other important drug aspect is the cancer. Cancer is ravaging our world these days, and trust me, snake venom has actually proven to be very, very useful in production of anti-cancer drugs. That's for chemotherapy and the like. And why this can actually make sense to you, like as I said, cytotoxic venom, this affects the cell, this kills cells. Cancer, usually we are talking about malignant cancer, not necessarily benign, the one that can even metastasize. So this is like a trigger for cell growth, that it's like spinned out of control. It keeps growing. That's what cancer is generally. So now, since this cytotoxic venom have a component in it that generally kills cell, if you now harness this and, as I said, purify it, synthesize it in the lab, produce as the drug, if you inject it to those cells, it's going to help you just keep killing most of those rapid and active cells. So you see, you are using what seems like a disadvantage to an advantage, if you really see sense in it, because I really do. So I think that's all for that point. The next point is going to be, snakes do not have external ear. So this is like my pinna, this external ear, but they do have internal ear. But so most times, even if we are here and we are talking, the snake will not actually hear you. My gender, this is where you guys come in. You now see snake and you start screaming and you're shouting. Yes, that is when the snake is actually going to hear you, because number one, the snake has to be the sound has to be very, very high before their internal ear pick it. And then as you are jumping and shouting, it's coming with a lot of vibration. They're able to pick vibration. So most times it might just be when you see a snake hanging on a tree, you sight it, probably not even seeing you, and it doesn't even hear what you're saying. It's just there relaxing on its own. All right, so the next one, very fascinating thing about snakes, they're actually cold-blooded. That means they are kilotherms. They are not homeotherms like us. For homeotherms, we're able to regulate our internal temperature by ourselves. No, they are not like that. They always assume or take the temperature of the environment. So if you're in a cold, so that's why there's no even need using, like there's a time where I was working with cobra, Nigerian Degree College, very next spitting cobra, and I just tried. It was funny. I said, let me just try it. I put a thermometer in it, and it did not read anything, because it was actually cold. So that means that most of our thermometers, there's a limit that they cannot pick up a temperature. I think they cannot pick less than 35 degrees, and they cannot pick higher than 40, 41. So if you're lucky, mercury thermometer can pick up to 42 degrees. So there's a limit. So I think it was very cold, most likely lower than the degree that it can pick. So since it's taking the snake is most likely taking the temperature of the environment, the thermometer could not pick it. Maybe if it was probably within range, like if the environmental temperature was within the range, the thermometer could pick, the thermometer would pick. So this is how the thermometer was just reading 0, and that was when I proved that fact to myself, that yes, snakes and a lot of other reptiles are able to take they are cold blood, they're able to take the temperature of the environment. So when the temperature is hot, you expect them to be active and they'll just be like this. If the temperature is very, very cold, like the temperature, you see they are so calm, they'll just be calm. They're just slow. And funny enough, even when you want to take in places where you want to take x-rays, one thing they do is if you pick up a snake and then you put it on the x-ray machine, like some place is very, very cold. Once it's cold, you just see that they'll just lie down. You don't even have to restrain them. They'll just lie down there and you do what you want to do, because any external temperature affects their body temperature. They don't have the mechanism to regulate it. And I really feel like that's very, very fascinating, honestly. So okay, so as I earlier mentioned, I said snake actually love the dark. They love their isolation. So most times when you see them entering your house, or on instances where you begin to talk about how snakes are entering your soccer bed, first of all, maybe keep your drainage system very well. Please seal up any opening. Maybe a rat or something enter there, it will attract them to your house. That's usually the issue. They're probably looking for food or shelter. So even if they enter, they avoid human beings. I've heard instances where a snake can be leaving somebody's roof for like how many years. They avoid you. It's just coincidentally. And especially if you're a poultry farmer, they're attracted to poultry houses. Why? The ammonia that is released from the feces or the excreta of this poultry attract them, and when they come there they feed on eggs. So make sure that things like rats, if your poultry houses are actually well covered, no holes for snakes to creep in, and there are no rats around, because rats, again, besides attracting them to your house, they can attract them to your poultry farm, and you know that that's a lot of problem for your birds and also you as a whole. So there's what we call cryptic coloration in snakes. This is that you cannot accurately tell the kind of snake, is it venomous or non-venomous, just from the coloration. This is because a non-venomous snake can just carry a color of a venomous snake and vice versa. So you can't use the color to tell that this one is venomous. So most time people say venomous snake, they look like. It's not true. There's cryptic coloration. It can actually be misleading. So I think yes, a lot was just going through my head. I hope I've done justice and I've successfully convinced you and not confused you that snakes are not so bad, and they are very, very important in our world, one way or the other, either directly or indirectly. And then you could just, based on the information, find out more online, learn more. If you have questions, you could drop it in the comments and I would attend to them. So thank you so much. Please keep supporting me. There might probably be a lot of errors. I'm still trying to get the hang of this and perfect how I transmit the information. So please share, like, subscribe, and if you have fascinating stuff about animals that you'd like to know, you can actually reach out.